Have you ever really stopped to think about what happens in that tiny little moment between typing in a web address and hitting enter? It feels like magic, right? Well, it's not magic, but it is kind of like a high-speed detective story. So let's dive in and uncover how this invisible engine of the internet, the Domain Name System, or DNS, actually works.
This quote just nails it, doesn't it? We humans are all about names. Google.com, things that are easy to remember. But computers, they live in a world of numbers, specifically long, clunky IP addresses like 93.184.216.34. There's just no way any of us are going to memorize a bunch of those. So that's the big question, isn't it? How on earth does the internet handle trillions of these translations all day, every day, all over the world without even breaking a sweat? Well, that's where our detective story really begins. At its core, the whole thing boils down to this one simple problem: names versus numbers. We need human-friendly names to navigate the web, but computers need machine-friendly numbers to find each other. And DNS? Well, DNS is the brilliant translator that sits right in the middle, connecting those two worlds. This brings us to the most popular analogy you'll hear for DNS. It's the phone book of the internet. It's a pretty good way to think about it. It's a massive, global directory that does one thing incredibly well. You give it a name, it gives you back a number. Simple as that. But as you're about to see, it's way more dynamic and a whole lot smarter than any old paper phone book. Every good detective story needs a hero, right? A detective who solves the case. Well, for the case of the missing IP address, the internet has its very own gumshoe. It's called the DNS resolver, and it does all the hard work for you. You can think of this resolver as your own private investigator. The moment you hit enter, you've hired it. It's usually operated by your internet service provider, and its one and only mission is to hunt down the IP address you asked for no matter where on the internet it's hiding. So how does our detective actually track down the right number? It doesn't just know the answer magically. It has to follow a very specific trail of clues, moving from one informant to the next in a logical order. Let's walk through that whole journey. Okay, here's the entire case file laid out. It all starts with you. Your request goes to our detective, the DNS resolver. It starts at the very top by asking a root server for a lead. The root server says, "I don't know, but you should talk to the server in charge of all .com addresses." So the resolver goes there. That server then points to the final authority, the one that has the actual answer. Case solved. The IP address gets sent back to you, and the website starts to load. Now, this whole process works so beautifully because of a really clever tree-like structure of servers, or in our story, a hierarchy of informants. The key is that no single informant knows everything, but each one knows exactly where to point our detective next. The very first stop is always a root name server. Think of these as the master index of the entire internet. They won't give you the specific IP address you're looking for, but they will look at your request and say, you're looking for a .com address? Go talk to that guy over there. And here is a wild little fact. The entire global internet, all of it, is bootstrapped by just 13 of these logical root server networks. That's it. They're spread all over the world, of course, but that small number really just shows you how incredibly efficient and elegant this system's design really is. So following that first clue, our detective goes to the next informant, the top-level domain server, or TLD server. This is the specialist for a specific domain ending, like .com or .org or .gov. So the .com TLD server knows where to find the official records for example.com. We're getting one step closer, and this brings us to the final informant, the one that holds the treasure. The authoritative name server is the ultimate source of truth for a specific domain. When our detective asks it for the IP address, this server provides the definitive, final answer. And with that, the case is cracked. So if you zoom out and look at the whole thing, you see this beautiful structure. It's like a tree. It starts from a single root at the top, which branches out to the TLDs like .com, which then branch out to individual domains, and then even to subdomains. This hierarchy is the secret sauce that allows the system to organize billions of websites and scale across the entire planet. Now, that whole investigation process is brilliant, but if our detective had to do that for every single click you make, well, the internet would be incredibly slow. So it has a secret weapon, a little trick to make everything lightning fast. Seriously, just imagine if every time you wanted to drive to your friend's house, you had to start from scratch by looking at a map of the entire world. It would be ridiculous, right? That's what browsing the web would feel like without this trick. So, what is this amazing shortcut that makes everything feel so instant? Well, the answer is actually really simple. It's a clever form of memory. It's called DNS caching. And here's how it works. When our detective finds an IP address, it just jots down the answer and keeps it handy for a little while. The next time you ask for that same website, the resolver doesn't have to go on that whole journey again. It just checks its notes and gives you the answer right away. And the benefits of this are huge. For you, it means websites you visit often load almost instantly, but it also means those super important root servers don't get hammered with the same questions over and over and over again. This speed trick is what allows the entire system to handle the unbelievable amount of traffic on the internet today. So, with that final piece of the puzzle, our case is closed. We've pulled back the curtain and seen how this incredibly elegant system works behind the scenes, acting as the truly invisible engine that powers our entire online world. And here's the most amazing part. That entire detective story we just laid out, all those steps, all those servers, it all happens faster than you can blink. We're talking about a few milliseconds. It's an invisible marvel of engineering